Welcome back, students. This is the Q&A session 6 from the playlist of oscillations. The topic is the energy of a particle executing simple harmonic motion. Now, based on this topic, I have selected one question which was asked in a number of competitive examinations long time back. So, the question which is written here on this board was asked in the MNR 1995. It was asked in the Delhi in the entrance examination of the Delhi College of Engineering in the year 2000, and it was also asked in the entrance examination of the Rajasthan pre-medical test in the year 1995. So the question here is: a particle is executing simple harmonic motion with an amplitude of 4 cm. At what displacement from the equilibrium position it will have half potential energy and half kinetic energy? So basically, we have to find the displacement from the equilibrium position of this particle at which it will have half potential energy and half kinetic energy, meaning that the potential energy at that displacement from the equilibrium position will be half of the total energy, and the kinetic energy of that particle at that displacement from the equilibrium position will also be equal to half of the total energy. So from these two equations we can simply say that the potential energy of the particle at that displacement from the equilibrium position will be equal to the kinetic energy, and since potential energy of the particle which is executing simple harmonic motion is equal to half k x square, so I can write that half k x square will be equal to half k a square minus x square, because the kinetic energy of the particle executing simple harmonic motion is equal to half k in bracket a square minus x square, where a is the amplitude of the simple harmonic motion, which is equal to 4 cm in this case, and x is the displacement of the particle from the equilibrium position. Now here k is the force constant. Now k, the value of the k is equal to m omega square, and we have already derived the equations of this potential energy, the kinetic energy and the total energy in the previous session, that is in the session number 5. So this session is basically in continuation of the session number 5. So from this equation we can simply say that this x square will be equal to a square minus x square, or we can simply say that 2x square is equal to a square, where a is the amplitude of the particle executing simple harmonic motion, and so x square will be equal to a square by 2. Now a is equal to 4 cm in this case, so this will be equal to 16 by 2, and this will be equal to 8 cm. Or simply we can say that the displacement of the particle from the equilibrium position, where the potential energy will be half of the total energy and the kinetic energy will be half the total energy, this will be equal to 2 root 2 centimeter, because under root x is equal to under root 8, so which will be equal to 2 root 2 centimeter. So the correct option here is B. So thank you very much for joining this session. In the next session I will be taking up a different type of a question from the same topic, that is energy of a particle executing simple harmonic motion. So till then, have a nice day. Bye.